Hello and welcome to another PyMOL Quickie with me, Dr. Ross. Today we will look at methods to extend protein secondary structure. As always, you can expand the description for the video timings and a list of the commands, and also please like and subscribe for new content. Just a quick warning that the structures that we're going to make today will require further refinement in pieces of software that can minimize that structure in order to account for bond angle and bond length irregularities that we'll probably be introducing using these methods. Furthermore, if you do wish to actually generate de novo structures, PyMOL is not the piece of software to do it. There's Modeler, which is a Python module, and various other pieces of software that can do it much better than this. So first things first, building your secondary structure from scratch and linking two secondary structural elements together. So this video is in response to a question that I was asked in the comments about how to extend a beta sheet of a protein structure. I thought first of all what we could do is we could fabricate that protein structure, and in the next section we'll do it on a native structure. So that means that the first thing I should do is introduce to you the fab command in PyMOL, which I've gone over in one of the previous tutorials. You can find the wiki page for this particular command on the PyMOL wiki, but it basically uses the command fab, your amino acid sequence of the peptide or protein that you are trying to generate, a object name for that peptide, and then a secondary structural classification which you will find on this website here. So for example, what we can do is if we want to make a helix, we can use the fab command with peptide as the amino acid sequence, and you can see here we've got this alpha helically arranged conformation of those particular amino acids here. And because we've used structural classification secondary structure equals 1, we've got ourselves a helix. We can equally go for secondary structure equals 2, and that you see gives us the extended beta sheet conformation, and we can go for secondary structure number 3, and that gives us again a extended beta sheet structure here. For the purposes of the rest of the video, I'm just going to take off the alpha helix there. Now, what's the difference between an antiparallel and a parallel conformation for these secondary structural elements here? Well, if we overlay them, we can see that really there's very little difference between those structures. Maybe we can see that the position of those hydrogen bonding elements involved in that secondary structure are in slightly different positions, which may be relevant, but of course the major difference between an antiparallel and a parallel beta sheet is the orientation of those chains in space relative to one another. So what we can do here is let's try making ourselves a little antiparallel beta sheet here. So the first things that we want to do is to move these sheets relative to one another, and so for this we switch to editing mode, which means that we click down in the bottom right corner anywhere on this little matrix of commands, and that switches us over to the editing mode. Now if we hold shift and left click allows us to rotate, and middle click allows us to translate. So what we can do is we can translate one chain away from the other. We'll make them into a anti-parallel conformation, and then we'll just try and repair that that bit of twisting that we've accidentally put into the molecule there. And we'll align these just by eye. This is why we're going to end up with very janky structures at the end of it, because we're doing things according to human eye rather than according to a set of parameters that we might otherwise be using a computational method in order to set these things. But we can see that, I mean, that kind of looks alright, doesn't it? We've got nitrogens and the oxygens, relatively speaking, pointing at one another. which should make a nice kind of a beta sheet interaction. What we'll also do is we can just type remove hydrogens, get rid of those, and that will make things a bit clearer. Now we want to add residues that are going to link together these two chains that we have here. So first of all, we're going to click on the S button down here. That's going to show us our peptide sequences. And what we want to do is we want to extend from the C terminus of our first peptide and attach that to the N terminus of our second peptide, which you can see are located proximally to one another here. So what we'll do in the viewing mode here is we'll deselect our selections, and then we'll move over to the editing mode again. And what we can do is make a pick. So click on the N terminus of one of the chains. We could equally click on the C terminus of another chain instead. Doesn't really matter which way around we do this. And then what we can do is hold the Alt button and type in some amino acids for our linker section. So we'll click here, we will hold Alt, and we'll just do SGSGS, and that will give us a long extended chain here. Now, while we're still inside the editing mode, we want to be able to move that chain, and to do that we're going to be using the sculpting options that's inside the build menu up here. So we're going to go to build, sculpting, auto-sculpting. Now what we can do is hold Control and left click and drag, and that will allow us to drag one chain like this. And what we want to do is position this chain so that it is close to, or in fact, what I kind of quite like to do with this is to get one residue overlapping another residue. What we can do, there we are, that's why I was getting confused there. Alright, so there's our side chain. And what we really want to do is knock this guy in the opposite direction there. That's made us a horrible cis bond, so there we go. And what we really want to do is we just want to make sure that the majority of those atoms that we have there are in some way overlapping with one another. Again, we don't need to be too precise when we're doing this, because I mean, presumably you're doing this for visualization. Sorry, so once you've got them overlapping to a degree that you like, you can just go back into the build menu and go to deactivate. And it's a good idea to then deactivate the auto-sculpting and deactivate the sculpting, and that means that we won't accidentally turn that back on in the future. Okay, so we've overlapped one of our residues of our chain here. So what we can do now is select that overlapping residue, and we can then go into selections here and just remove that, and that leaves us with a nitrogen and a C-terminal carbon, which are within peptide bond distances. And obviously, if you spent some more time doing that, you could make those angles also appropriate. So we're over now in the viewing mode, or if you're not, then you want to switch over there. We've selected our either the terminal nitrogen, but because we overlap the whole amino acid, it'd be the terminal amino acid here, and we've removed that. And now, of course, we have a problem here, is that the numbering, we want to be able to make this into a single chain here. And if our numbers overlap, as they do, that will cause PyMOL to confuse which bits are in which atoms are parts of which amino acid. So what we need to do here is we need to make sure that the numbering of these residues is different before we turn them into the same chain. And to do that, we're going to use this command called alter. So we've added -3 residues onto our peptide there, and our peptide is 7. So is that going to be 11? Let's just try that. So what we'll do is we'll select chains our C-terminal peptide, and we're going to add 11 onto the residue count for each of those. So that gives us then peptide here, which starts at 1. And you can see the 6 is over the D, which means that the E is the residue number 7. And then we start at 8 for our second chain. So now we can extract these as an object. So we'll just say, what we'll first of all do is we'll remove that object. And what we can then do is just say select all, which is a nice easy command to select everything here. And then what we can do is, because that's under the selection here, we can just go and say extract object. And now objects 2 and 3 that we originally made are empty, and this new object, object number 1, has everything in there. And now what we need to do is link together our C and N terminal break, which we have here. So we go into editing mode, we click on the 2 atoms of interest there, and we just type bond. And there we go. So that's how to make a very janky looking beta sheet that's been attached by a polypeptide chain there. Now, as I say, this is fine for the purposes of illustration, but if you were going to go and try and use this for anything further, then you'd need to go through other methods of refinement with pieces of protein design software, or maybe molecular dynamic minimization methods as well. Okay, so there we go. Thank you very much. Part 2, extending a natural structure. So the original question which was posed to me was, how can I make an extension of a part of secondary structure? So I thought I'd go over that with an example using this particular chain B of this particular PDB here. So we can load that in, we can remove all parts of that which are not the polymer, because they will just be getting in the way. We can type the word orient so that we bring the molecule into the center here, and we can see that we've got 2 beta hairpins here. If we extended this beta hairpin on the right, we would potentially increase the amount of total secondary structure by allowing an extension here to interact with some of the beta sheet which is already stabilized on this part of the chain by this point here, increasing the total secondary structure, and that might be of some use for something that you're doing. So what we need to do is we need to make a selection of the area in which we want to extend, and the easiest way to do that is to go down into the sequence button here. We shall say as sticks, because all of those cartoons don't really show us enough information here. So what we want to do is extend part of it. Now you can see here that the beta sheet loses its structure around here, so that would be a bad place to include that kink. But what we could do is include from here to here, for example. So now that we've selected these 2 residues, which is the starting place of where we want to extend, we can see that that's selected those particular residues in our sequence, and now we can quite easily just select and fill in the missing residues in between that. What we want to do then is to go to our selection, which we've just made here, and say copy to a new object. And that means that now if we turn off the original, we've just got our part here that we want to extend. For convenience, we will change that into a blue color so that it's different from our green color of our original. Now in the editing mode, we want to use this rotation and translation, which is basically means we can hold shift while in the editing mode and use left click to rotate and middle click to translate. And seeing as we've selected the blue guy here, which is on top, we should be able to middle click and drag. And what we can do is we can go from our initial position here, and let's just say we want to make an extension of 2 amino acids. So you can see the initial nitrogen here will move to the next nitrogen, but because of the concertina of that backbone, that means everything's out of sync. But if we move to the next one, that should mean that that those things will overlay a little better. So let's zoom in on that first one. And again, middle click and dragging, not using the rotate button because we don't really want to rotate it at the moment. What we can do is we can overlap it so that the nitrogen here is really very much on top of that initial nitrogen. Now, because we're in the editing mode, what we can then do is click on this one here. That makes a pick, as we've described before. Now, once you've made a pick in the editing mode, and then you do the hold shift left click and rotate, what will happen is we'll rotate around that pick. So basically that pick will stay stationary and allow us to rotate the rest of the chain around that. And you can see that by, well, I can just show you now, for example. So I can hold shift, and you can see that I'm now rotating around that pick that I've made. So this is shift and left click. So repick that guy. And what we want to do is we want to get these two nitrogens now on the opposite side as close together as possible. So we'll hold shift and we'll just rotate those so that they are reasonably close together. There's only so close that you actually can get them. And what we can now do is, as you see, so here's that first pick that we had, and here's our other guy here. So now I'm going to use the translate by holding shift, middle click and dragging. I'm just going to try and make these two atoms, the distance between these, kind of equidistant, so that there's as much error in one as there is in the other, and that'll do. So now we've got our blue guy extending from the green guy. So what we can do is we want to remove the green residue here, the green residues that are now no longer being used, so we can click on those. We can do the same thing, fill in the middle here, and then we can go to our selection and remove those atoms. And that leaves us now only with that extension that we've made. Now, in the first part I was talking about how the numbering gets changed. So what we need to do is sort out that numbering again. So just to recap here, after doing the translations and rotations in the editing mode, I switched to the viewing mode, selected the old loop and removed it. And now what we're going to do is repair the amino acid numbering. And we can use this alter command in the exact same way that we did before. So for example, we extended each of these different chains by 2 residues. So what we can do is we can select the extension here, and we can add an additional 2 amino acids towards those numbers. And then what we can do is select everything on the C-terminal side of that extension and add an additional 4. And that will correct our numbering so that that's all right. And now in the exact same way as previously, we can extract to a single object. So we can say select all, extract a new object. Now of course that empties our previous 2 objects and just leaves us with our single object here. And then in the editing mode we can make 2 picks and say bond, make 2 picks and say bond. And because we use the overlapping structures to do that, rather than doing things by eye, we made very small manual alterations there. You can see that those bond angles are a little less janky than they were in the previous one. Maybe this guy here could do with a little bit of repair, and we can do that in the editing mode by holding control and then left click and dragging that atom in order to be in a slightly more sensible place. And then again, what you can do is you can add this you can save this molecule, put it through some minimization of some method or another in order to accommodate that. And of course, if once you've made that extension, you need to repair the actual amino acid sequence, we can go into the wizard here, go into the mutagenesis tool for proteins, and then you can just sequentially move through those amino acids that we had. I hope that helps. Thank you very much. See you next time. Thanks very much for watching. Hope that was useful. Please see the longer tutorials which I've put together and are available. Tutorial number 1 and tutorial number 2 are very good. And of course, like and subscribe for more content. See you next time.